Hi everyone, so today we're going to be talking about the operations on imaginary units. Now we did talk about imaginary numbers today, the number I, okay, which we talked about it just being a way to represent the square root of a negative number, the square root of -1. But we can also perform operations using addition, subtraction, multiplication, and division using I. So addition, we add I just like we do real numbers, and we treat it almost like a variable. So we can only add the like terms. So in this case, the parentheses actually don't really matter because all of the operations are addition. But I would add the 2 and the 4 because those are the real numbers. And then I'd also add the imaginary parts. So 3i and 5i is going to give me 8i. Now, this is written in the form that we talked about. This is called A plus BI form. And I like to call that standard form, but oftentimes we're going to refer to it as A plus BI form, remembering that the A is the real part and the BI is the imaginary part. Okay, so we can kind of treat it like it's its own variable, although it's a number. Now, subtraction with imaginary numbers, you have to be a little bit careful because, again, parentheses and negatives change things. So, for example, I see that I'm subtracting these 2 units. That negative that's in front means that I have to turn everything inside the parentheses to its opposite, kind of like distributing a negative. So I need to make each one of these their opposite sign. So -6 minus 3i. Now I still have that 5 minus 2i. So now I can combine the real parts and combine the imaginary parts. So I'm going to combine the 5 and the -6, which is going to give me -1. And then I'm going to combine the -2i and the -3i, and that's going to give me -5i. So my final answer, -1 minus 5i. And again, that is in A plus BI form. All right. So that's addition and subtraction. Now multiplication with complex numbers is a little bit trickier. So first let's try and multiply. These are 2 binomials, and when we multiply just like we would if it was 3 plus x and 3 minus x. Now some of you may notice that these look familiar. This is actually the result of the difference of 2 squares, or how I refer to it as dots, right? The difference of 2 squares. But I'm going to prove to you that it's going to do the same thing that dots does. So if I make a Punnett square for this, my little Punnett square, and I'm going to multiply 3 plus I and 3 minus I, I get 3 times 3, which is 9, 3 times I, which is 3i, 3 times -i, which is -3i, and then I times -i would give me -i squared. So if you notice, these are opposites, so they cancel. So I'm left with 9 minus I squared, which really does look like the difference of squares. Remember, this would be 9 minus x squared. All right, now here's the only tricky part. We've now multiplied these 2 binomials with the imaginary number. We now have to address the elephant in the room. The elephant in the room is I squared. In class, we talked about the fact that I squared is another way to represent the number -1. Because I squared, if we take the square root, if we take I and the square root of -1 and we square it, well, this cancels out the square, so I'm left with -1. Well, you squared I, so it became I squared. So then I plug it in, and I get 9 minus -1. Being really careful, this means a negative times a negative, which becomes a positive, so 9 plus 1, so I get 10. All right, let's try one that's a little bit harder. So my point to this one actually is that you really only have to, it is the difference of squares, you only have to multiply the first terms and the last terms because these middle terms will cancel out like they did here, as long as they're dots. All right, so looking here, I recognize these 2 binomials are dots. They are the same binomials but with opposite signs. So I multiply the first terms by the first term. Root 2 times root 2 is root 2 squared, which is 2. And then I do I times negative I, which gives me negative I squared. I deal with that big old fat elephant in the room, so I plug in a negative 1 for I squared, making sure I put it in parentheses. Really important, because it means you're subtracting a negative 1, so it becomes 2 plus 1, which is 3. All right, so what you might have noticed is in example 3 and 4 that these were the patterns, that these were dots, these were the differences, two squares, that they were the same numbers but with opposite signs. These are called complex conjugates. Okay? And the product of complex conjugates, when I multiply them, product means multiply. When I multiply them, the result will always give me a real number. I'm sorry about that, real number. Like it did for us. It gave us 10 and it gave us 3. Those are real numbers, not imaginary numbers. All right, guys, thanks for listening.